but just make the other one the appropriate one. So we've got a equals 5, b equals 12, and c equals 13. We're going to compare c squared to a squared plus b squared, okay? C is 13, so 13 squared. A is 5, 5 squared, plus b, which is 12 squared. 13 squared is 169. 5 squared, 25, and 12 squared, 144. If you add these together, you get 169 compared to 169. Those are equal, right? Just put equal signs all the way through. And what happens if c squared equals a squared plus b squared? It's a right triangle, okay? We're pretty solid at this, right? Okay, good. Let's do one more. Let's do number 10. First off, can these make a triangle? 5, 7, and 8? Yes, why? Exactly. The two smallest numbers, which are 5 and 7, if you added those together, you would get 12. Is that bigger than 8? Yep. Now let's go ahead and figure out if it's going to be acute, obtuse, or right. We've got to take C. Which one's going to be C? 8, because it's the biggest. And then A and B. So we've got A squared plus B squared compared to C squared. A squared is 5 squared plus B, which is 7 squared, C, which is 8 squared. 25 plus 49 compared to 64. 25 plus 49 is, I think, like 74. Yeah. And then this is 64. So which one's bigger? 74. So we fill in the greater than sign all the way through. What happens if C squared is less than A squared plus B squared? It's acute. Very good. So this is an acute triangle. Yeah.
Do you have to do that first part where you add 5 and 7?
Only if it asks, okay? Because it said verify that the segment lengths form a triangle, that's why I did that first part, okay? Because what if it gave you like 13? When we're talking about right triangles, there are some instances where we just have to do the manual labor. And there's other instances where the angles tell us some really cool information about the right triangle, and it makes the problem super duper easy, okay? The first example that you guys need to know is when we have a 45, 45, 90 triangle, okay? In a 45, 45, 90 degree triangle, the hypotenuse is the square root of 2 times as long as each leg. So in the diagram, okay, notice how each of the legs is A units long, right? Do you guys see that? This length is A and this length is A. The hypotenuse will always be the square root of 2 times the value of A. Now, just so we get a little bit smarter, let's go ahead and prove that this is true. If these two A's are my legs, let's make one of them A and let's make the other one B, right? So then A root 2 is what? C, right? A squared plus B squared equals C squared. Let's go ahead and plug in our formula. A squared plus B squared equals C squared. Now we're gonna substitute in a, and a root 2. So we're gonna get a squared plus a squared equals a times the square root of 2 squared. Okay, what is a squared plus a squared? Can we simplify that? Can we simplify this left side? Let's say you had x squared plus x squared. What does that become? If we have x squared plus x squared, what does that become, guys? 2x squared, right? So a squared plus a squared is going to be 2a squared, okay? Now let's say we squared this portion on the right. This is going to be a squared times the square root of 2 squared. That's different, okay? So we use FOIL when you have like a plus the square root of 2. If there's a plus or a minus, then you have to FOIL. If it's just multiplication inside the parentheses, you can take that exponent and just distribute it to each one, okay? What's the square root of 2 squared? 2. So this is 2a squared equals a squared times 2. 2a squared equals 2a squared. Okay, now if this confused you, just write it down. You don't have to look at it again. This is just the proof of where this comes from, okay? The proof that if we have a 45, 45, 90 triangle, we know that the hypotenuse is going to be the square root of 2 times the length of one of the legs, okay? If this made sense to you, all the power to you. But guys, this was just the proof. You're not going to need to know this or anything in the future. I just wanted to show you guys where this is coming from. We didn't just make these numbers up, okay? Second thing, if I were to define this triangle as another form of a triangle, what could I say about this triangle? It's a right triangle, but is it anything else? Caroline? Very good. It is isosceles. Why is it isosceles? Both of the legs are congruent, and we have two angles of 45 degrees. Do you guys see that? Two angles of 45 degrees. So it is an isosceles triangle. Okay, let's see an example of 45, 45, 90, okay? If our leg is A, our hypotenuse is A times the square root of 2. Find the value of x. How do we know that this is a 45, 45, 90? Anthony? Good. But why does this angle have to be equal to this one? Christina? Very good. Our legs are the same length, right? If your legs are ever the same length, it's always going to be 45, 45, 90, okay? So this is 45 degrees, and this is 45 degrees. So now let's go back one slide. So if our leg is x, this 6 is going to be equal to x times the square root of 2. And then let's rewrite this over on the right. So we've got 6 equals x times the square root of 2. All we do now is we divide by that square root of 2. Divide by the square root of 2. And we get x equals 6 divided by the square root of 2. Boom, we're done. That's it. Now, some people might be like, where in the world did he get this from? The more we do it, the more it'll make sense, okay? That's the only thing you need to know though. For 45, 45, 90, If you have two legs that are the same length, automatically 45, 45, 90, and your hypotenuse is 2, or the square root of 2 times one of the legs, no matter what, okay? All right, moving on. So you're 60. The other case that you guys need to know is the 30, 60, 90, okay? In a 30, 60, 90, the triangle hypotenuse is twice as long as the shorter leg, and the longer leg is the square root of 3 times as long as the shorter leg. So what we do in these instances, guys, is we make A the length of the shorter leg. The longer leg will then be A times the square root of 3, and the hypotenuse will be 2 times that shorter leg length, okay? Now, when you're looking to identify, okay, but how do I know which one's going to be the shorter leg? It's whichever one is opposite the smallest angle, right? So whichever side is opposite the 30 is your smallest leg. Whichever side is your larger leg. And then obviously the hypotenuse is the one that's opposite the 90-degree angle. Okay, peeps, this is all the new information we're learning today. We've got 3 more examples, and then we're done, okay? There's only 2 cases we're learning today, the 45, 45, 90, and the 30, 60, 90. Let's do this thing. Example 2. What kind of case is this? 45, 45, 90 or 30, 60, 90? 30, 60, 90. So this right here, or this last angle is 30 degrees. Why? Christian, why is it 30? Very good. 180 degrees, you take away the 60, you take away the 90, you're left with 30 degrees, okay? So this 5 is going to be our smallest side because it's the smallest one. It's across from that 30, okay? So this is our smallest side. Let's label it A, okay? X is then going to be equal to A times the square root of 3, and Y is going to be equal to 2 times A. So we've got 3 equations. We've got A equals 5, X equals A times the square root of 3, and Y equals 2 times A. So if A is 5, what's X going to be? Five root 3. And what's Y going to be? 10. Easy, right? Okay. Now, normally, if we were only given one side of a triangle, we can't apply the Pythagorean theorem, right? Because we would have 2 variables and we would only have 1 equation. So there's no way we could figure out the length of the other 2 sides. But in special triangle instances, if you know one side, you can figure out the rest of them, okay? But it has to be a special right triangle. So it has to either be a 30, 60, 90 or a 45, 45, 90, okay? So if you're ever given one side only, look for the special triangle instances, okay? If you're given 2 sides, forget about it. Just use the Pythagorean theorem, okay? Questions? All right, moving on. The diagonal of a square has length 6. What is the perimeter of the square? Well, let's draw a square. That's actually a really nice square, guys. I'm proud of myself. Okay, and we also want to draw the diagonals. Here's one diagonal. Here's another diagonal. And I'm not doing this in Notability, so bear with my squiggly lines. Okay? The length of these diagonals, it told us, is 6. The full length of the diagonals is 6. Now, there's some special information that we know about the diagonals of a square. Who remembers what we know about the diagonals of a square? They bisect each other. So this is going to be equal to this, and this is going to be equal to this. Okay? What else is special about the diagonals of a square? Christina? They're 90-degree angles. Very good. They intersect at a 90-degree angle. So let's take any of these right triangles and let's see what we do. So go ahead and highlight this one on the right. Let's do this one on the right. Okay, so we know it's a right triangle. Do we know the length of this side that I put a question mark on? Any ideas? Anthony? 3. Very good. Why? Very good. It's half the length of that diagonal. Awesome. What's the length of this one? 3. Very good. Now, this is where we have to remember one of those theorems that we kind of never used, okay? One of the theorems that we didn't really use before is that the diagonals of a square are also bisectors of those angles. So this angle is cut in half. This angle is cut in half. And if those angles are cut in half, what are their measures? 45. Because they were originally 90, right? Based on the definition of a square. And if we cut them in half, they have to be 45 degrees and 45 degrees. Let's say we didn't remember that though. I'm going to erase everything I just wrote. Let's say we didn't remember that. How do we know this is a 45, 45, 90 scenario? Let's say we didn't remember that theorem. How do we know this is a 45, 45, 90 scenario? Christian? But let's say we didn't know that. Christina? Okay, yes, I'm with you. The diagonals are equal, but now we're looking at the right triangle, right? They're not the diagonals anymore. What are they? The sides, the legs. The legs of this triangle are equal, right? So it's an isosceles right triangle. It's got to be 45, 45, 90, okay? It's got to be 45, 45, 90. So this last side of this square is going to be what? Let's label this x. X is going to be equal to, let's see if anyone can figure it out. It involves that 3. What do you think, Caroline? Very good. 3 times the square root of 2. Because remember, this section is just whatever the leg was times the square root of 2. Okay? That is the definition of a 45, 45, 90 triangle. So x is 3 square root of 2. But what was our question asking for us, Vinny?
What the perimeter was.
How do we find the perimeter if we know one side of a square?
You just multiply it
By?
by 4.
Very good. So we take 3 root 2, and we multiply it by 4. Because there's 4 sides, all those sides are equal. We get perimeter equals 12 square root of 2. Boom, bada bing, we're done. Was that too hard? Okay, you guys with me so far? We got one more example, and then you guys are good to go. Cool? Okay, here we go. Last example. An equilateral triangle has an altitude length of 5. Find the perimeter of the triangle. What does equilateral mean? Emma? And what else? They're all 60-degree angles, and what else? Christina? Excellent. All the sides are the same length. So all these angles are equal, all these sides are the same length. It says the altitude is length 5. What's the altitude, peeps? What is altitude of a triangle?
The height.
It's the height. So let's go from the top. Draw a nice line down to the bottom. It's 90 degrees. And its length is 5. Okay. Any ideas on what kind of right triangle scenario this is? Christina? Good. Why? I see a 90 and I see a 60. Excellent. Okay. So this one has to be 30 degrees. 30, 60, 90 scenario. Okay. Now it gave us the side opposite the 60, right? Normally, this is equal to A times the square root of 3. Okay? Because it's opposite the 60, not opposite the 30. This 30 degrees correlates to the side that's so we've got the hypotenuse of 2A, the short side of A, and the medium side of A times the square root of 3. Let's solve for A. The only thing we know is that 5, so we have to use this equation. A times the square root of 3 equals 5. How do we solve for A? Yep. Divide by the square root of 3. Very good. So A equals 5 over root 3. Who can tell me what's the length of one of the sides of this triangle? What's the length of one of the sides of the whole triangle, the equilateral triangle? What do you think?
Is it 10 over the square root of 3?
How'd you get that?
Well, A is just half of it since it's bisected.
Mm-hmm.
Then the other half will have to be the same because we have times 2, which is 10.
Very good. Do you guys agree that this side is 2 times A? And A was 5 root 3, so just multiply it by 2. Okay? So this 2A is going to be now 2 times 5 over root 3, which is just 10 over root 3. But it asks us for the perimeter. So what do we do with that 10 root 3? 10 over root 3. What do you think, Anthony? Yeah, you just multiply by 3. 10 over square root of 3, multiply by 3. What do we get? 30 over the square root of 3. All right, when you're done.